For inverse, what we need to remember is our inputs become outputs and our outputs become inputs. Or another way to think about it is our x's get switched with the y's, right? These turn into y's, and the inputs x's become the outputs y's. These become the x's. So all we're doing is really swapping the x's and y's. So first thing we do is plug in the y for f of x, just so it makes things easier. And now what we do is make this output of y into an x. And this x, make that into a y. And since we want the y to be the output, well, let's just solve for it. So let's get it by itself. So I'll subtract 6, get x minus 6 is equal to 4y. And then we need to divide by 4. Now we want to make sure we distribute it to both. So I'm going to get x over 4 minus 6 over 4 also is equal to y. But the 6 over 4 can reduce to 3 over 2. So I'll just switch this around too. So I'll put the y on the left side this time. And I'm left with x over 4 and minus 3 over 2, which is, if you can see, d. We can put the f inverse back in if you want, but you can already see the answer. Right, for number 5, what we need to do for this one, remember all the points in the shaded area are the solutions. So we got to figure out which one of these represents it. So which one of these has those solutions? So all we do is let's choose a solution. Maybe something in the shaded area like 0 for x up 1, 2, 3, 4, 5. Maybe something like 0, 5. Whoops. 0, 5. So I'm going to test 0, 5. It should work for both inequalities if it's a solution. So I'll just plug it into the first one, and I get for a, I'm going to put in 5 for y is greater than 1. That works. Then if I plug in x and y into the second equation, because remember it has to work for both to be a solution to the system, I get 5 for y is greater than 3 times 0 for x plus 3, and I get 5 is greater than 3, which is also true. So must be A. For number 6, what we want to do here is we have to realize that this is an exponential function, and we're talking about the graph of it. So our first question is it growth or decay? And since 2 is greater than 1, right, any number, every time we have the base or the growth factor greater than 1, then this tells us it's going to be growth. In fact, our number is going to double over and over again, so it's going to get bigger and bigger and bigger. So if you remember, growth we can think of kind of like our right hand. I don't know if I can draw very well. So if you hold your right hand up, it makes this shape. Right? So I know it's going to look like this, and I also know that there's no h or k, so my asymptote is going to be on the x-axis. So that's kind of what the shape of this graph is going to look like. It's going to have this shape, and then the asymptote is going to be the x-axis. Now the only thing we have to think about now is which of the following values of x would produce a point closest to the x-axis or closest to the asymptote. Well, we want to think, is it a number that's going to be further to the left for my x or further to the right? Well, let's see, if I follow the graph further to the left, we get closer and closer and closer and closer and closer, but we never touch it, but we get closer and closer to the x-axis. If I go to the right, it gets farther away. So if I want to get closer, I need to go to the left, so which of these is furthest to the left? If you don't know by looking at the fractions, then do the long division, at least for one decimal point. So I know that 1 divided by 2, or if you don't know this already, well, it goes in 0 times. Then if I add a 0, it goes in 5 times, so 0.5. If I do 3 divided by 5, well, maybe you might know that this is already bigger than a half because it's more than half of the halfway to 5. But let's see, it goes in 0 times, we add a 0, goes in 6 times, so 0.6, so it is bigger. Then I have 3 divided by 7, this should be smaller than a half, but let's just double check. 7 goes into here 0 times, so I add a decimal. 7 goes into 30 4 times. And it goes on, but we can stop there. unless we need to. And then 7 divided by 9, 7 goes to the left, or goes into 7. 9 goes into 7 0 times. Then 9 goes into 70 7 times. So which is furthest to the left if I were to graph it? Well, that's the smallest number, which is 0.4, which was 3/7. Number 7, what we have here is, if you recall, we want to first check the intercepts, because those are easy. All we do is plug in and cover up and see what we get. Then we'll put in slope-intercept form and see if they're parallel or perpendicular. So checking the intercepts first, if I plug in a 0 for y, then I'm going to end up with negative 2x is equal to negative 8, and that's x is equal to 4. Then I do the same thing here, plug in 0 for y, I'm going to get negative 2x is equal to 3, and if I divide that, I get x is equal to negative 3 over 2, which is not correct. So they don't have the same x-intercept. Then we do the same thing for y. We're going to plug in 0 for x to find the y-intercept. So if I do that, I get negative 4y is equal to negative 8, because this cancels out. Right? If I plug in 0, and I get y is equal to 2. Same thing here. If I plug in 0 for x to get my y-intercept, I get negative 4y is equal to 3, which is y is negative 3/4. So we see, okay, no, that's not correct. So it's not the same y-intercept either. So now we have to actually put them in slope-intercept form, or at least do the first part of it, to see if they have the same slope or opposite reciprocal slope. So that's what we're looking for. If it's the same slope, it's parallel. If it's opposite reciprocal, it's perpendicular. So let's see, we have negative 2x minus 4y is equal to negative 8. So to put in slope-intercept form, we have to get y by itself. So if I add 2x to both sides, then I get negative 4y is equal to 2x minus 8. Then if I divide by negative 4, I'm going to get y is equal to negative 1 over 2 x, and this is going to be plus 2. So my slope here is negative 1/2. If I do the same thing for the other one, let's see, I have negative 2x minus 4y is equal to 3. And if I solve this, I'm going to get plus 2x. So negative 4y is equal to 2x plus 3. And when I divide by negative 4 again, I'm going to get, this reduces again to negative 1/2. And so since we have negative 1/2 slope here, we have a negative 1/2 slope there. They're the same slope. Which one is that? That's parallel. So our answer is B. Right? If you remember, whenever we have a graph and want to see if it's a function, then we have to use our vertical line test. So to check if this relation's a function, we'll do a vertical line test. If it crosses more than once, it's not a function. Right? It can only cross at most once. So if you notice here, I just went straight down and oh, that's bad. We crossed right here and we crossed right there. So we crossed more than once. We crossed twice. So is it a function? No, it's not. So the relation is not a function. Well, this one's not a function. And this one says not a function. So it's either B or C. Now to find the inverse, we just think about switching the x and y axis. So you can turn it sideways in your head and do a vertical line test again, or you can just do a horizontal line test, I guess. And if you imagine doing this again sideways, everywhere I go, when we do it sideways, those are only cross the graph once. Once here for that line, once here for that line. So this one is a function. The inverse is a function. So that one's not correct, so it must be this one, C. For number 9, this one's really easy. If you remember, this 3, the denominator is always the root for an exponent. So the denominator is always a root. So another way to write this is the third root of 125. And then the top still stays as an exponent, so we'll do this squared. Well, what's the third root of 125? It's just 5. And if I square that, our answer is 25.